What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
On the night of July 1, 2025, the Atlas telescope in Chile recorded a shocking sight, a strange object moving just beyond Jupiter's orbit. Only hours later, the speed data stunned the scientific community. The object was racing at nearly 70 kilometers per second, moving twice as fast as Earth orbits the Sun and completely beyond the pull of gravity. It was not an asteroid and it was not a normal comet, but a rare visitor from outside the solar system. If its path brings it close to Earth, the question becomes unavoidable. Are we truly safe? The discovery of Comet 3I Atlas did not happen by chance. It was made possible because of a telescope system called ATLAS, located high in the mountains of Chile. This system is designed to scan the skies for dangerous objects, especially those that could one day collide with Earth. On July 1, 2025, ATLAS caught a faint signal, a tiny point of light moving against the background of stars. To most people, it looked like nothing important, just another small dot lost in the universe. But the astronomers knew at once that something unusual was happening. The first measurements showed the dot was almost 670 million kilometers away, inside the orbit of Jupiter. At that distance, even a small body should have appeared dim, but what caught attention was the speed. It was traveling at nearly 70 kilometers per second, which is about twice the speed at which Earth circles the Sun. The scientists quickly realized it was not bound to the solar system. That speed was far beyond what could be explained by gravity alone. It was passing through, a traveler from the galaxy itself. Size estimates soon followed, and they shocked even veteran astronomers. The object could be between 5 and 50 kilometers across. To put that in perspective, the asteroid that wiped out the dinosaurs was only about 10 kilometers wide. If something that large were ever on a collision course with Earth, the results would be catastrophic. While 3I Atlas is not expected to hit our planet, its size made it the largest interstellar object ever observed, a record that instantly put it at the center of global headlines. Within days, the object was officially named Comet 3I Atlas, or C2025N1, by the International Astronomical Union. The 3I marked it as only the third interstellar object ever discovered by humans. Before this, the world had only known about two such visitors, Oumuamua in 2017 and Comet Borisov in 2019. Both had challenged scientists in different ways, but now 3I Atlas offered something even more important. It was big, active, and caught early enough to study in detail. For scientists, the discovery was like being handed a rare book from another world. Every measurement, every image could reveal secrets about how planets and stars form in distant systems. The timing was critical because most interstellar objects are spotted too late, already fading into the distance before telescopes can focus on them. This time, however, the world was ready. Teams from Europe, Asia, and North America joined forces, rushing to collect as much data as possible before the comet moved behind the Sun. The discovery also captured public imagination. Newspapers spoke of a cosmic messenger, while online forums were filled with speculation. Some wondered if it might hide alien technology, while others feared a hidden threat. NASA had to release official statements calming fears, confirming that the comet would not strike Earth. Yet the unease remained, because its arrival was a reminder of how fragile our place in space really is. So the question became clear. If this interstellar comet is only passing through, how can scientists be sure it is truly from beyond our solar system? The most important clue that told scientists that Comet 3I Atlas was not from our solar system was its unusual path. Almost every planet, asteroid, and comet that belongs to the Sun follows an elliptical orbit. These orbits are controlled by gravity, which pulls everything into a repeating cycle. But when the first data on 3I Atlas arrived, astronomers noticed that its trajectory was not elliptical at all. Instead, it followed a hyperbolic path, which meant it was not bound to the Sun. It was moving so fast that it could never be captured, and once it passed through, it would continue into the darkness of space, never to return. The speed of this comet was another key detail. At nearly 70 kilometers per second, it was traveling much faster than anything native to our solar system. For comparison, Earth orbits the Sun at about 30 kilometers per second, while Jupiter moves at around 13 kilometers per second. Even the Parker Solar Probe, the fastest spacecraft humans have ever built, needed complex gravity assists and still could not match the comet's natural speed. No object that truly belongs to the solar system could move at such a velocity without eventually slowing down. This was a clear sign that the comet came from beyond. Astronomers also studied the angle of its arrival. Most comets and asteroids orbit near the same flat plane as the planets, called the ecliptic. 3I Atlas, however, came in at a steep angle, almost as if it had been launched from a completely different neighborhood of the galaxy. Its retrograde motion showed that it was not connected to the usual flow of objects that circle the Sun. These details told scientists they were watching a visitor, not a resident. Brightness measurements offered even more evidence. Normally, objects inside the solar system grow brighter as they approach the Sun because sunlight vaporizes surface ice, creating a glowing coma. In the case of 3I Atlas, the brightness pattern was inconsistent. Sometimes it displayed a faint halo, and other times it seemed dimmer than expected. This irregular activity matched what scientists saw in previous interstellar objects and proved that it behaved differently from typical comets born here. Another critical point was that its hyperbolic excess velocity was measured at about 25 kilometers per second. This is the speed it would still have even after escaping the Sun's gravity. No local object could gain that much energy on its own. The only explanation is that it formed around another star and was ejected into space, wandering for millions or even billions of years before reaching us. This fact makes every observation of 3I Atlas an opportunity to study the chemistry of another solar system without leaving our own. Together, these factors created an undeniable case. The comet's path, its extreme velocity, its unusual angle, and its inconsistent activity all pointed to one conclusion: it did not come from here. The Sun could not hold it, and no planet could have launched it. It was a traveler from deep space, carrying the history of another world on its frozen surface. If scientists can prove where exactly this comet came from, then the next question is just as exciting. What happens when it gets close enough to show signs of life through its chemical makeup? One of the most striking features that confirmed 3I Atlas was not just a rock, but a true comet, was the sudden appearance of a coma. A coma is the glowing cloud of gas and dust that surrounds a comet when its icy surface begins to vaporize under the heat of the Sun. At first, astronomers noticed only a faint haze around the object, almost like a soft halo. That delicate glow was enough to suggest that sunlight was reacting with frozen material on its surface. Soon, more than 100 follow-up observations from around the world confirmed the presence of a visible coma and even the first traces of a tail. This meant that 3I Atlas was not only an interstellar visitor, but an active comet, releasing material that could be studied directly through telescopes. The size of the coma itself was surprising. While it was still faint compared to bright comets like Hale-Bopp, the fact that it could be detected from hundreds of millions of kilometers away was extraordinary. Each time the comet was observed, the coma shifted in brightness and shape, reminding scientists that interstellar visitors do not follow predictable rules. They can behave one way under certain conditions and completely differently under others. This irregular behavior has made every observing session critical because data can change in just a matter of hours. Astronomers quickly calculated the path of 3I Atlas, and the timeline they mapped out became one of the most important parts of the mission. The comet would reach its closest point to Mars on October 3, 2025, passing close enough that orbiters around the red planet could get a direct view. Then, only a few weeks later, on October 30th, it would reach perihelion, the closest point to the Sun, at about 206 million kilometers, which is just inside the orbit of Mars. Unfortunately, during this period, the comet would be on the far side of the Sun relative to Earth, making it nearly impossible to observe directly from our planet. This was a frustrating reality, but scientists knew that patience would be rewarded. By early December, 31 Atlas was predicted to reappear from behind the Sun, giving astronomers another chance to observe its coma and tail before it began to fade. On December 19, 2025, the comet would reach its closest approach to Earth at a distance of about 1.2 astronomical units or 180 million kilometers. While this was still far away, it was close enough to allow detailed monitoring using some of the largest telescopes on Earth as well as instruments in space. After that, the comet would continue its journey outward and likely remain visible to powerful telescopes until sometime in 2026 before disappearing forever into interstellar space.
It's moving at a velocity of about 135,000 miles per hour, so it's going really fast.
The significance of these dates cannot be overstated. Each one represents a unique opportunity to capture information about the comet's structure, its chemical makeup, and the way its activity evolves over time. Unlike objects native to the solar system, interstellar comets like 3I Atlas give us only one chance to observe them. Once they leave, there will never be another opportunity. That urgency has pushed the scientific community to coordinate observations across continents, ensuring that not a single window of visibility is wasted. But perhaps the most fascinating aspect of all is that its behavior is still unpredictable. Some nights it shows a thin tail, while on others it appears strangely quiet, as if hiding its true nature. That mystery has led to the next big question. How does 3I Atlas compare with the two famous interstellar objects that came before it? Before Comet 3I Atlas shocked the world, in 2025, astronomers had already encountered two interstellar visitors that completely changed how we look at the universe. Each one carried its own mystery, and together they set the stage for why 3I Atlas is so important today. The first was Oumuamua, discovered in October 2017 by the Pan-STARRS telescope in Hawaii. Its name means scout in Hawaiian, and that description could not be more accurate. From the very beginning, Oumuamua did not behave like anything seen before. It shot through the solar system on a hyperbolic path, confirming that it came from beyond the sun's reach. But what truly surprised scientists was not just its speed or trajectory, but its strange physical features. Observations suggested that it had either an extremely elongated shape, like a giant cigar, or possibly a flat pancake-like form. No asteroid or comet in the solar system had ever looked like that. Even more puzzling was its acceleration. After passing close to the Sun, Oumuamua sped up slightly, but telescopes could not detect any visible tail or gas emissions that would normally explain such movement. Comets usually gain speed because of jets of vapor escaping from their icy surfaces. Oumuamua showed none of that. This unexplained acceleration led to wild speculation, including the controversial idea that it might be an alien probe or even a light sail, a type of spacecraft powered by starlight. Most scientists eventually dismiss the alien theory, pointing instead to unusual outgassing or surface effects, but the truth is that the object remains unsolved to this day. Just 2 years later, in 2019, the second interstellar visitor was found. This time it was discovered not by a professional observatory, but by an amateur astronomer, Gennady Borisov, using a homemade telescope in Crimea. Named Comet 2, I/Borisov, it looked far more familiar. It had a bright coma, a long tail, and chemical signatures that matched many comets born inside our solar system. Spectroscopy revealed the presence of cyanide gas and carbon-based molecules, proving that its composition was similar to local icy bodies. Borisov showed the world that comets could survive long journeys through interstellar space while still looking and behaving like the ones we already knew. Together, Oumuamua and Borisov painted two very different pictures of interstellar objects. One was strange, almost alien in its behavior, while the other was comfortingly normal, almost a twin of comets from our backyard. And that is where 3I Atlas becomes so fascinating. This new object seems to be something in between. Like Borisov, it shows signs of activity with a coma and occasional tail, but unlike Borisov, its brightness and emissions are inconsistent. Sometimes it looks alive, releasing gas and dust, and other times it appears quiet, as if it is hiding its true form. This mixture of features has made scientists eager to compare all three side by side. Oumuamua forced us to question whether all interstellar objects are unique, while Borisov reminded us that nature often repeats patterns. Now, with 3I Atlas, we face a puzzle that blends both. Is it simply a comet behaving strangely, or could it be the first hint that interstellar objects fall into different categories? If that is true, then studying this one could reveal entirely new rules about how planetary systems are built across the galaxy. The question now is clear. If 3I Atlas stands between the extremes of Oumuamua and Borisov, what does that mean for its origin story, and what secrets might its chemistry hold about worlds beyond the Sun? The discovery of Comet 3I Atlas is not just another astronomical event. It is a chance to look directly into the building blocks of other worlds. Every comet carries frozen material from the time it was born, and that material holds the story of how its home system formed. For astronomers, studying 3I Atlas is like opening a time capsule, one that may have been traveling through the galaxy for billions of years before reaching us. One of the most important questions is about its chemical makeup. By measuring the light reflected and absorbed by the comet, scientists can detect which molecules are present in its coma and tail. If the composition of 3I Atlas looks similar to comets from our solar system, it might mean that planetary systems across the galaxy are built from the same raw ingredients. But if it contains rare or exotic molecules that we do not see here, the comet could prove that different stars produce planets in very different ways. This would help answer one of the biggest mysteries of astronomy. Is our solar system unique, or is it just one of many repeating patterns in the Milky Way? The origin of the comet is also a subject of intense study. By tracing its trajectory backwards, researchers believe it came from the thick disk of the Milky Way, a region filled with some of the oldest stars in the galaxy. If this is correct, then 3I Atlas could be more than 7 billion years old, older than the solar system itself. That possibility makes every detail about its structure even more valuable because it could hold frozen material that predates the Sun and Earth. Imagine studying ice that formed around a star long gone, carrying a record of chemistry that shaped planets before our world even existed. This is also why interstellar comets matter for the search for life. Organic molecules like carbon chains, alcohols, and amino acids have already been found in comets from our solar system. If 3I Atlas shows similar molecules, it could mean that the seeds of life are spread widely across the galaxy. On the other hand, if its chemistry is completely different, it might tell us that life is not a universal story, but something rare and fragile. Either way, the results would change how we think about humanity's place in the cosmos. Theories of how such objects escape their home systems are still being developed. One idea is that giant planets, like Jupiter in our own system, can act as slingshots, kicking comets into interstellar space. Another possibility is that when stars are young and unstable, they eject large amounts of debris into the galaxy. 3I Atlas could be a survivor of one of those violent beginnings, launched into the void billions of years ago and wandering ever since. Its survival across such distances shows that interstellar comets can endure incredible journeys, carrying with them the fingerprints of their birthplaces. The scientific meaning of 3I Atlas is therefore twofold. It can confirm whether the chemistry of planets is shared across the Milky Way, and it can reveal how objects escape from their homes to become cosmic messengers. But these answers depend on how much we can observe before it fades away into the dark. And this raises the next urgent question. If interstellar visitors can hold the keys to such big mysteries, how can humanity ever catch one before it disappears? When 3I Atlas was confirmed as an interstellar comet, the next question appeared quickly. Could humanity ever reach it? In theory, sending a spacecraft for direct study would give priceless data. But in reality, the task is far more difficult. With a speed close to 70 kilometers per second, 3I Atlas is simply too fast for any existing spacecraft to catch. Even the Parker Solar Probe, the fastest machine humans have ever built, would fail to intercept if launched in pursuit. This creates a massive technical barrier. To chase an object like this, we would need entirely new technologies, such as giant solar sails, nuclear propulsion, or extreme gravity assists. Yet all of these remain only on paper. Some projects, however, are being designed to prepare for the next visitor. The European Space Agency is building Comet Interceptor, a probe that will wait at a stable point in space. When a new interstellar object is spotted, it can launch quickly and intercept the path. NASA is also studying a similar idea under the interstellar probe concept, which may be developed in the next decade. Both projects focus on the same goal, creating a fast reaction system instead of chasing something that has already passed us by. The challenge is not only speed, but also time. 3I Atlas will remain within our reach only for a short window before leaving the solar system forever. If we miss this chance, the opportunity vanishes, leaving a gap in knowledge we cannot replace. That is why preparation in advance is the key. The appearance of 3I Atlas shows how urgent this problem is. If another strange visitor arrives within the next few years, will humanity be ready to launch a mission immediately? Because one day, the visitor might not be harmless. It could be a giant body on a collision course, and then the question will no longer be, can we study it, but can we save ourselves in time? And this leads to another puzzle. Why is it that only now are we seeing more of these interstellar travelers? Throughout billions of years of the solar system's history, countless visitors from other stars must have passed by. Yet humanity has recorded only 3 so far. This does not mean they were not there before, it only shows that we could not see them. Space is too vast, while these objects are small, dim, and moving incredibly fast. Even a few decades ago, many of them likely slipped past us completely unnoticed. The change came from technology. Large-scale sky surveys, such as Pan-STARRS in Hawaii and Atlas in Chile, have already expanded our ability to detect faint travelers. But the real breakthrough is the new Rubin Observatory in Chile. Armed with a 3.2 gigapixel camera and a massive field of view, it can scan almost the entire night sky within only a few days. During early testing, Rubin discovered over 2,100 new asteroids in just a few hours of observation. This means that if an interstellar rock passes through in the modern era, the chance of missing it is now very small. Because of this, many scientists believe we will soon see not just 3, but dozens or even hundreds of interstellar objects in the coming decades. This is not only a scientific step forward, but also a shift in perspective. Instead of seeing them as rare accidents, humanity is beginning to realize that the galaxy is full of such wanderers. Each one carries the story of its birthplace, and with more samples, we can finally search for patterns. However, this also brings a new challenge. The more visitors we find, the greater the chance that one of them may pass dangerously close to Earth. A body several kilometers wide striking our planet would mean unimaginable destruction. That is why observation is not just a matter of curiosity anymore, but also a key part of planetary defense. Technology has opened our eyes to the universe, but it also leaves us with a hard question. What if one day, instead of only passing by, an interstellar traveler heads straight for Earth? 3I Atlas is not only a block of ice drifting in space, but it is a rare window that lets us look into worlds beyond our solar system. It carries a story about origins, about how planets form and change, and maybe even a clue about life itself. The real question now is, are we truly ready to face the answers that come from the deep universe? If you want to follow the journey of this visitor and explore more hidden mysteries, make sure to like, share, and subscribe so you never miss what comes next.